Welcome you all once again, and I'm myself Meghamala from Electronics and Communication Department, working as Assistant Professor from Institute of Aeronautical Engineering. And I'm here to talk about the conditional statements. So, what are the conditional statements? In order to write a particular syntax, or else in order to write a code, we need to go through some statements. Okay, already in the last class we had discussed different types of statements. Okay, when it compared with the syntaxes followed with the syntaxes, and also we had discussed the statements pertaining to the keywords that we are used. Okay, the keywords that we are using in that particular continuous, or else the net declaration statements or the continuous statements. So here in this conditional statement, what does the word conditional statements mean? So as a word conditional statement means that the condition, there is some condition. Okay, you all know what is a word condition means. So here when it comes to the Verilog, here we have different types of statements to be discussed. But here in this conditional statement, it states that if-else statement. The conditional statement is nothing but if-else statement. If is a condition, right? So wherever the if follows, the next it follows with the else. So if is a condition, so which is nothing but the conditional statement is about the if-else statement. So this is used to make a decision as to whether a statement is executed or not. So as here, the statement, conditional statement is nothing but the if-else statement, and it will help us, or else this statement used to make a decision. Okay, in order to make some decision, usually we will follow this conditional statements. So here in this particular, we have a statement, and here is equals to, and in the previous classes we had discussed, when it comes to the expression, this is a logical operator, this is equals to is assignment operator, this is assignment operator, and here in this statements we have the RHS. To the left of the assignment operator we have the LHS. So here also when it comes to the conditional statement, here we have equals to the right hand side the expression if is a condition, isn't it? So if is a condition with the expression, and this statement talks about the statement or null. So here if is followed with an expression, and the statement, that is the statement, or it could be no statement, that is null. And here we have the parenthesis, and here we have the bars, right? So here in this two way we can write the conditional statements. Okay, so we can write the conditional statements in order to make the decisions whether the particular thing has to forward it or not. So if expression and the same statement with statement or null, and else. I said you conditional statement is nothing but the if-else statement. So here my if, the condition followed with the else. So else statement, and then the statement with the followed with the statements and parenthesis and the end module. Okay, this is just a gist of how to mention, or else how to reflect the if-else condition statements in the syntax. So the expression is to be evaluated. Already in the last class we had discussed how to evaluate the RHS with respect to the LHS followed with the assignment operator. Okay, followed with the assignment operator. So here the expression needs to be evaluated. How? If it is true, that is it has non-zero value. So true means what? If it is true, we represent true with 1, isn't it? Then false with F, we represent it with 0. So the expression is to be evaluated either in terms of 1 or 0. That is non-zero value means true, and the 0 value means it's false. And the first statement which executes is if it is false. False statement has a 0 value, okay, or the value x or z. The false statement, it will have 0 or the value x or z. We all know what is x and what is z. Okay, x and z are the don't care conditions, and as well z represent the high impedance state. Okay, z represents the high impedance state, whereas x represents the don't care conditions. Okay, so whenever in the expression you are coming across in the condition, if you are coming across the false, that is a 0 value, okay, then that 0 value can be represented with the don't care and as well as the high impedance state. So the first statement does not execute it. When you come across this such kind of things, then always remember that the first very case will not execute. And if there is any else statement, okay, if the condition is followed with some 0 value or else with x or z value, then represent that that particular condition will not evaluate, and then we goes to the else expression. So in the else expression, if the statement and the expression is false, okay, then the else statement executes. That means what? Here my condition is when it is true, then it will execute. If my condition is false, that means if it is 1, then it will execute, and if it is 0, then it will not execute. Then if this particular sentence is not executing, if this particular statement is not executing, then I can go to the else statement. In this else statement, the expression false, the else statement will make the expression false to be executed. Okay, that's how the conditional statements work. So if expression, and here if expression is equals to 0. Okay, so mainly understand the thing here. When my condition is 1, then it will execute. If it is not, then I have to go to the else, and then my condition will execute. So this is how the syntax follows. If condition 1, okay, if is a conditional statement, if the condition 1, the statement is 1, and then if condition 2, statements 2. Okay, if here in this statement 1 and statement 2, if as per the binary value, that is true or false, as per the 0 or 1, if it is 1, then it will execute. If it is 0, then it will not execute, isn't it? So if it is executing, then it's well and fine. If not, I'm going for the else. So here else statement 3, and then I'm moving on to the another statement followed with the if. Okay, if, else, I'm moving on to the another statement if, the condition 3, and then the statement 4. Okay, this condition 3, else is the statement 3, but the if condition goes against to the statement, that is the condition 3, and then the statement 4, then followed with the else if. If it is not, then else if. What next? What if? So condition 4, and then follow the statement, and then else, the statement, if condition 5, and then it is begin. So here you will see there is some the statements or the conditions are not going as per the sequence. It's all based on the conditions that you are considering. The proper evaluation that you are making, as per the evaluation, the if else condition goes on. Okay, so begin the statement 7, 8 and end the statement else, begin again with the statement 9 followed with the statement and then end. So here the statements and the conditions, we will be evaluating all the statements as per the conditions that you are considering. If condition is possible, then it's well and fine. Otherwise, we are going with the else and then else if. Okay, likewise, it continues. Okay, until we achieve. Next, conditional, that is if else statement. Usage is similar to the if else statements of C programming. Okay, can't you understand? Did you notice this particular syntax? When you observe with respect to the C language, there is a much similarity that we are seeing, right? So in the Verilog and as well as in the C program, we see there is a similarity when it comes to the conditional statement. Okay, you see the similarity with respect to the C program, except the parentheses are replaced by begin and end. So except the keywords begin and end, the rest of the syntax is same like the C program. Okay, so coming to the construction of if else if. In the previous we have discussed only if else, isn't it? If and else, and now we'll see how the statements, how the conditional statements followed with if else and if. So the conditional statements occur often, that is worth a brief separate discussion. So here if else followed with again if. So here we will see it is a separate discussion with this, which is followed with respect to the if else condition. So if the statement else if and statement and goes on with the else if statements and else. Okay, and so here if else if else if else. Okay, that is how the expressions would be considered as per the condition. So here the sequence of ifs known as if else if construct. So if you see the sequence of if else if else if like that. Okay, so if you see the sequence of ifs is the most general way of writing a multi-way decision. So here if you are seeing a constant or else appropriate way of conditioning the statements if else and so on, then you are saying that it is the most general way of writing a multi-way of decision. So if in order to take a multi-way of decision, then the best possible way to approach is if else construct. Okay, if else if construct. So the expressions are evaluated in order, whereas in if else, only in if else conditional statements you see the evaluation is not in a properly ordered. Okay, evaluation is not in a proper order, not in a proper order. Whereas if you consider if else if, here the evaluation would be in a order. Okay, evaluated will be the evaluation of the sentences or the statements will occur in the order. So here in if any expression is true, the statement associated with that particular condition will be executed. This is also we have discussed in the previous class, right? If any statement is true, then the expression executed, then the expression will be executed. Okay, and this terminates the whole chain. So unless if you find anyway the true statement, then remember that we will be ending up the statement then there itself. Why? Because here when the expression is true, then I can easily execute the sentence. Okay, I can easily execute the statements. Then if each statement is either a single statement or a block of statements. So here the statements could be a single statements or a block of statements. So you can see sometimes a single statement or else a block of statements. Okay, statements. Then the if else statements controls the execution of other statements. So here if you are considering only if else, if you consider only if else, this if else statement, okay, this if else statements, it executes the other statements in programming language like C. If else controls the flow of program. So when you compare the Verilog if else conditional statements with respect to the C program, always remember that in the C program we will see the flow of the program continues. Okay, the program, the flow of the program, it controls and it continues. Whereas in the here also in the HTL same, the if else statements, it controls the execution of the other statements as well. You don't see any blocking of the statements in between. Okay, the flow will, it controls the flow of the execution of the statements. When you compare with the C language, it is similar. Then when more than one statements need to be executed for an if condition, then we need to use begin and end. So here keyword begin and end are used only if you are executing more than one statement. If you are executing a particular statement, then no need of using the begin and the end keyword. But whereas here, if you are executing more than one statement, okay, continuous execution of statements is been occurring, then always remember that if we need begin and end, okay, the statements would be executed more than one statement. If you find, then you have to use begin and the end. So here the syntax follows. So this is about the if, only if condition. So if condition followed with the statements. For example, if else, okay, if you have a condition that is to be executed, if else, then if condition, statements, else followed with the statement. So it's very simple, isn't it? If else, if condition followed with the statement, and else followed with the statements again. And then the nested if else, if, nested if else if. So it is a rate condition of the if else statement. We see here the nested if else. So here what happens is, we have declared the statements with the if condition followed with the statements, and then if else if, right? So else if condition followed with the statements, and then else statement. So here what did you observe? It is called as the nested if else if statements, right? So here we are seeing more than one conditions statements has been occurring, right? If you are arising like, or else if you are facing more than one conditions, then obviously it is good to implement the nested if else if statement. So how we implement is, first if conditions followed with the statement, and next else if conditions followed with the 2 or 3 statements, and finally with the else, and then followed with the statements. And that is how the nested if else if statements goes on. And other statements, other conditional statement we see here is simple if. Okay, so when it comes to the simple if conditional statements, the thing, like the syntax we need to write like this: module, simple if, register latch. Okay, latch. What is a latch and flip-flops? They are the storage devices, right? They store 1 bit of devices, 1 bit of information. Via, enable, de-input, and always at the rate. So here, always is a keyword in the behavioral modeling. In order to write a particular syntax, always is a keyword we need to specify, okay, before the initial. So always at the rate, enable or de-input. If condition occurred here, if enable, what happens here? If my bit is enable, if my selection is equals to 0 is enable, what happens? Then I have to begin. What should I begin? I should begin my latch less than or equals to de-input. Okay, my latch, if this condition, if condition arises, that means what? When s is equals to 0 is enabled, for example, then my latch will becomes de-input, less than or equals to de-input, and I'm ending up with the terminating with the end module. This is what, only it's a simple if. Okay, if you come across a simple if conditional statements, this is how we need to write a particular syntax. Okay, this syntax will be followed here. We have to consider the latch. Okay, and for different combination circuits, we can also write the syntax followed with the, if any case, if any conditional statements, if you want to consider simple if, by using simple if conditional statements, we can easily frame out the particular syntax. And if else, previously we had discussed only a simple if, right? For simple if, that is what the syntax that we need to follow. And now, if you come across a conditional statements, if else, for this if else, module if else, the register, D flip-flop. Okay, this is a D flip-flop, and for this flip-flop, I have a clock. For this flip-flop, I have a clock, D in, reset, set reset. Okay, and then see, always at the rate positive edge. So here in the in this flip-flop, we have discussed always the positive edge and as well as the negative edge. Positive edge and as well as the negative edge. Okay, so always at the rate positive edge clock, and then follows the condition. here the condition that we are considering is if else. So here if reset, we have set and reset, isn't it? Set 0, 0, 0, 1, 1, 0 and 1, 1. This is how we need to follow. So set and reset. So if my condition I'm considering the reset, then I'm beginning with the if my reset is something 0, then D flip-flop is less than or equals to 0, and then I'm ending up with the terminating, and again I'm starting up. Like why? Because if else, right? So else, then I'm beginning again with the condition D flip-flop which is less than or equals to D in. So here you have to observe, one is with respect to 0 and with respect to input. Okay. Then finally end module. So this is nothing but the if else. So when you come across a simple if, you will find only a if followed with the condition and followed with the statement and ending. If you come across any if else statements, then if condition followed with always at the rate, and we need to begin. Why? Because here I'm using here I have two conditions to follow. One is with respect to 0 and one is with respect to input, D input, isn't it? So I'm so for this reason my begin and I'm using end statements. Okay, in between I have to write the conditions, whether it equals to 0 or less than or equals to the input that you are considering. So this is a bit difference between the simple if and the conditional statement for the if else. And coming to the nested if else, nested if else if statement. So what does this nested if else if statement says? In the previous slides we had discussed if statement, simple if, okay, if else if, and nested if. So for this nested if, we will see if condition followed with the statements, else statements, and else if statement and else, and then end module. Okay, this is nothing but the nested if. So when you observe here, this is a module nested if. Okay, module nested if, we are talking about the nested if else if, right? So module nested if, and here I'm considering register 3:0 counter. So totally 4 bits of register I'm storing. Okay, counter. Now register clock, reset, enable, up, enable, down, enable. So here as it is a counter, I can go with the up counter or else down counter with the enable pins, up enable, down enable, enable and reset and clock pin. So here this is in the net, I'm having all these terms and goes with the always at the rate positive edge clock. So here it is in the behavioral modeling that we are considering all these examples. So in the behavioral modeling, always remember that we always at the rate, always is a keyword that we have to follow. So always at the rate positive edge clock. So here if is asserted, what if the condition is asserted? Then if, that is if reset is double equals to 1 bit which is equals to 0. Okay, if this is a condition, then I have to begin my counter. Why? Because I have considered a circuit code counter. If reset is equals to 1 with respect to 0, that is my counter is 4 bit. 0, 0, 0, 0. It is a 4 bit. And now if my counter is enables and up count is asserted. Now my counter is enabled and that too up counts. What happens? The conditions goes like this. Else if, okay, else if I enable 1 bit up counter, okay, it counts 1 bit, right? Up count, it counts 1 bit, 1 bit, 1 bit, and so on. So my counter, it becomes counter plus 1 bit, isn't it? From 0 to 10, for example, I need to count. How will I count? C equals to 0. Then counter plus 1. Like this, 1 bit, it will counts, it increments. So here that is what we are seeing. So if is done with the condition reset is equals to 1 followed with the counter enable, that is up counter, and then else if Else if I'm enabling now with the enabling of up counter, up n. Okay. So else if 1 bit, and if down counter, enable down 1 bit. And now I'm beginning my counter, it will count. If it is a down counter, if it is up counter, it counts plus. If it is a down counter, minus. So here down and 1 bit, it begins the counter minus 1. So the counter which is less than or equals to counter minus 1. Okay, if it is enabling down counter, counter minus 1. Enabling the up counter, counter plus 1. Okay, this is a difference that you need to observe. And then if counting is disabled, okay, if counting is disabled, what happens? Else begin the counter less than or equals to count. If counter is disabled, again we need to count it right from the starting. So again it will begins. What begins? The counter will begins its count. So here we see the redundant count. That means what? We see the repetition of the counts. When the counter is disabled, okay, when the counter is disabled, again we need to count it right from the starting. Then we see that counter less than or equals to counter. That means what? The redundancy code, the repetition of the bits will occur. Okay, so that code is nothing but the redundant code, and I'm ending up with the end module and the module. So this is how you need to write if you come across any module, any combinational circuit that you are considering. Always, if you want to write some syntax in followed with the conditional statements, nested if else if, then this is a procedure. So in the exam point of view, it is very important and it's very easy to understand as well. So here in the example, we have considered the counter, right? It counts, up counts and down counts. So enabling of 1 bit, up counts of 1 bit. That is, it gives the highest priority, and the down bits, up count means highest priority and the down counts means lowest priority. It enables down enable of 1 bit, that is negative 1 bit, it counts down, and for the up counter it counts 1 bit up. So here it is highest priority it gives, whereas the down counter it gives the lowest priority. So here we don't include normally the reset checking in priority. So here sometimes what happens, we don't use the reset pin. Okay, normally we don't use a reset pin, but here when you observe this particular figure, we have the inputs. Okay, and for this flip-flop, D is the input. All the D consists of it's a combination of many inputs, and here you have a reset button, and the Q is the output, C is the clock. So for this particular, we need the priority logic. So in order to know the priority of the bits, okay, whether you are taking the up counter, where, or else you are taking the down counter, if you want to know, okay, if you want to know, or else if you want to need the priority logic, then in order to know this priority logic, we use the nested if else statement. Okay, remember, if you want to know the priority concept, or else if you want to know the bits in a which priority, highest priority or lowest priority, whatever it is, then we use the nested if else statements. And then it is a known fact that priority implementation takes more logic to implement the parallel implementation. So here, when you are considering this, or else when you want to know the priority of the bits, whether it is up or down, always remember that the more logic is to be needed in order to drive in the parallel implementation. Okay, in order to drive the parallel implementation, in order to save the delays, in order to reduce the delays, and if you want to drive the particular combinational circuits, wanted to know the bits, whether it is up counting or else down counting, in order to know the given priority, always remember that the logic need to be implemented than the parallel, that it takes more logic to implement in the parallel implementation. So here what you have to do to know the inputs in the mutual exclusion, you can code the logic in parallel if. So here, in order to know it more, what is another alternative that we are going is using the parallel if. So using the parallel if, we can easily parallelly, simultaneously, the concurrency can be achieved. Okay, the concurrency can be achieved between the combinational circuits that you have considered. So module parallel if, and here my counter, 4-bit counter, it counts from 0, 0, 0, 0, right from the starting 0, and then via, for this counter I have a clock, reset pin, enable pin, up enable, down enable, and always at the rate passage if reset is asserted. Okay, if reset is enabled, then what happens? If reset is asserted, if reset is equal to 0, then it begins with the counter less than 0, 0, 0, 0. It's a 4-bit counter, right? So 0, 0, 0, 0, 4-bit. And then I'm ending up with this and this particular thing. Again, else, what if not? If counter is enable up counts, okay? If my counter enables the up count, what happens? Same. It's like a previous syntax follows. Enable is equals to 1 bit. That is up counter, up enable. It begins and the counter less than or equals to, as it is up counter, it counts a 1 bit, right? So counter plus 1 bit. Okay, counter plus 1 bit, and I'm ending. And again, as it is a nested if-else if statement, so if counter down counts, what happens? Parallelly, I just wanted to know the priority. In order to know the priority of the bits, up counts or down counts, this is a procedure that I'm using. So in this procedure, parallelly, I'm counting up and as well as I'm counting down using the if-else if statement. So if counts is enabled, the down count is enabled more. So if enable 1 bit, if it is a down count of 1 bit, it comes down, and the counter becomes the count is which is equals to less than or equals to counter minus 1, as it is count down, counter minus 1, and module. Okay, so this is what all about. If you want to know the priority of the bits when it comes to the counters, if you want to know the priority of the up counter or the down counter, the best way to implement or else to know the priority, going for the conditional statements, parallel if else is a best one. So this is all about today's topic. So today we had learned about the conditional statements, if conditional statements, simple if, how to write a particular simple if, and also we had discussed about the nested if else and nested if else if. Okay, nested if else if, and parallel if else. Next, if condition followed with the if else if. This is what we have discussed. So in all these things, always remember that when you're writing a particular code, always at the rate. Okay, always at the rate is a keyword need to mention. The initialization of this keyword is must, and always after the initializing of this keyword, followed with the begin. Okay, and followed with the statements. In the statements, you will come across if followed with the statements, and else followed with if else statements, and followed with the and module. Okay, this is how the syntax should be written when it comes to the conditional statements. Though it is if condition, or else if you are using any if else if condition, simple if condition, and nested if else condition, and as well nested if else if condition and parallel if else condition. So this parallel if else condition is a special conditional statement where here in this parallel if else conditions we will able to know the priority of the bits. Okay, especially when you count, when you are considering a combinational circuit counter, ring counter, whatever the counter that you are considering, if you want to know the priority of the bits, whether it is up counting or down counting, parallelly you can know the priority by using this parallel if else conditional statements. Okay, and this is all about today's topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.